Okay, so for this spell work, we're going to take a look at a closer look on how to add fractions, but more specifically, how do I add a whole number to a fraction? And then we're going to look at dividing again. So how do we divide when it's in this type of format? So notice that this is kind of like a fraction over another fraction, but this one whole piece is like a fraction. So the numerator has a fraction and the denominator has a fraction. But all this really means, remember, fraction is really just division. It's saying that I'm taking 1 over 25 and dividing it by 3 over 5. So we'll take a look at that here in a sec. But let's take a look at the first one here. If I want to add 4 with 1 over 3, well, first I need to make this 4 a fraction. And I can do that by putting the 4 over 1. So that's what I'm going to do first. And then what I need to do is, let me move this over just a little bit. I need to multiply, or actually before I go into that, this denominator is a 1 and this is a 3. We learned yesterday when we want to add fractions, we need a common denominator. So our common denominator, let's think of one. So if I have a 1 and a 3, maybe I want the denominator to be a 3, right? Because I can multiply this one by 3 and the top by 3. So if I multiply the bottom by 3, the bottom will be 3. So that will give me my common denominator as 3. And then 3, anything you multiply to the bottom, you got to multiply to the top. So that's why I have a 3 on this 4. So 3 times 4 gives me 12. Plus just 1, because I didn't have to change this denominator at all because it was already a 3. So I don't have to multiply anything to this fraction. So just 1. So 12 plus 1 gives me 13 over 3. And I think I can't simplify that, so that's my answer there. All right, so now we're going to take a look at the fraction one here for division. So this here is really just saying I'm taking this fraction and dividing it with this fraction. So let me write this to something that you guys are more comfortable with, and that is 1 over 25 divided by 3 over 5. When we do division, what happens with the second fraction? Well, if you remember, it actually flips. So we take the second fraction and we flip it because that allows us to divide, right? So we keep the 125 the same, so we keep the first fraction the same. We flip the second one, and then we multiply straight across. So that division sign becomes a multiplication sign. And if we multiply straight across, before we do that, let's actually see if we find any common factors to cancel out and make this easier on us to divide. So like I noticed 25 and 5 have factors in common. What divides into 25 and 5? Well, 5 divides into both of them. So 5 divides into 25 5 times, 5 divides into 5 1 time. So if I multiply straight across, 1 times 1 gives me 1. 5 times 3 gives me 15. And so 1 over 15 is the simplest form. So this is my answer. Okay, keep these skills in mind. We're going to be dealing with a lot more problems where we're adding with maybe whole numbers. And also this here is the stuff we're going to be talking about today. So this is a special type of fraction when you have a fraction over a fraction. This is what we call a complex fraction. A complex fraction, actually, let me just switch to the next slide here and I'll talk more in details on what that means. All right, so a complex fraction is basically a fraction where the numerator or denominator or both contain a fraction. So if you take a look at like this first example here, notice that here's your fraction line, and in the numerator, I have a fraction in it. It's 5x over 12. And in the denominator, I also have another fraction, x squared over 36. And then this one here, notice the fraction line's right here, and this is all in the numerator. Notice that you have a fraction with a whole number, or like another fraction with a whole number. there. So complex fractions can have fractions in the numerator and denominator. Okay, so rule of thumb for solving. You want to simplify the top and the bottom separately before you try to divide. If you remember what we did before, what we're going to do is we're going to try to check if the top is simplified and the bottom simplified. If it is, we're going to divide because fractions just mean division. So let's take a look at this top here. So our top is 5x over 12. Now, that I can't really simplify any further. So that's really already simplified. So I'm taking 5x over 12 and I'm dividing it by, well, let's take a look at our bottom part here. This piece looks like it's also simplified, like x squared and 36 can't simplify any further. So I'm going to bring the way it is down, or over, that's what I mean. So I'm taking this fraction and dividing it by this, and that's what I wrote here. Basically just rewrote the problem in a different format. This format's something that we're more used to. So if this is a division, then that means we have to flip this fraction here. So let's go ahead and do that. So that means I have 5x over 12 times, remember we switched that division sign into a multiplication, 36 over x squared, because I'm going to flip that fraction. From here, I want to see, well, I would have to multiply straight across. But before I do that, let's be strategic and cancel out any like terms or any like factors. So what I spot is that the 12 and the 36, so diagonally, they have common factors. Like in this case, 12 can divide into 12 one time, but 12 can also divide into 36 3 times. So 12 and 36 both can have 12s in them. Whereas this diagonal, I have a 5x, and so there's an x here, and I also have an x diagonal to it. So remember what we learned, if this x is to the first power, right? Well, then I can cancel that out because that's lower, and so I would cancel out this one and take away one x from it. So that's going to be 2 minus 1, which is just 1. So when I really look at this fraction right here, all I'm left with is a 5. And then the bottom, just a 1. So 5 over 1 times this top part here has a 3 and then x to the first power. So 3x to the first power. And when I multiply this straight across, I just have 5 times 3, which is 15. 1 times x to the first power, which is just x. So 15 over x, and that is my answer. Because this is all I can reduce down to. I can't simplify any further. So we're going to do that here next. So like I said, you want to separate the top, simplify the top and bottom separately. Okay, so looking at this fraction here, what I'm going to do first is write my line here. This middle fraction line, I'm just going to transfer it right on over. Now I'm going to just look in the numerator. So the numerator is this guy here. And I'm going to try to combine I'm going to try to add this fraction with this one. Well, how do I do it? Well, think about the bell work here. This is a whole number. So I need to put this 1 over 1, right? So now there are 2 fractions. Well, I need a common denominator next. So we got to choose a common denominator. Well, this is an x, this is a 1. So maybe a good denominator to choose here is x. Now, why would I choose x? Well, it's because this one's already an x, and this one here, to make it an x, all I have to do is multiply it by x. And if I multiply the bottom by x, I have to multiply the top by x. So, in this case, this fraction I don't need to multiply anything with because it's already an x. So I don't have to multiply anything because it's already the common denominator. So the top here is just a 1. And then I have a plus sign in between, so I'm going to carry that plus sign over. And then I have 1 times x, which is just x. and that's it for the top. If I look here, can I add these two terms? Doesn't look like it. So this is all I have when I combine the top. So the top is simplified. Now we're going to do the bottom. So the bottom's just the same. We're going to take the 2 and subtract it with the 3 over x. So to subtract, I need to make sure that they have common denominators. But this 2 is not even a fraction yet. So let's make it into a fraction by putting it over 1. From there, we need to figure out a common denominator. So our denominator here is also a 1 and an x. So perhaps a good denominator is to use the same one as before. So just x. So that means I need to multiply the top and bottom by x on this side. However, this fraction already has an x in the bottom, so I don't need to multiply anything to this 3. So if I multiply the x with 2, I get 2x. Oops. 2x minus 3. And so now when I look at this here, I've simplified the bottom and I've simplified the top, so I finally get to divide now. So if I'm dividing, this is really going to be this fraction divided by this. But if I'm dividing, remember, this second one that I'm dividing by, when I put it over here, notice it gets flipped, right? So the bottom fraction is the one that gets flipped and then multiply. So instead of writing this step, which is really not necessary, I'm going to skip this step and go straight to the multiplication or multiplying by the reciprocal. So here's what I'm going to do. I'm going to take this fraction, bring it down. So 1 plus x over x, and then multiply by the reciprocal of the bottom. So this I'm going to flip and put it right here. So that's going to be x over 2x minus 3. And so when I look at this, I notice that the x's cancel diagonally because they're both the same. And then it looks like if I multiply straight across, I just have 1 plus x in the top, and then the bottom just 2x minus 3. So that's going to be my answer. Okay. And that's it. I can't really simplify any further because 1 and x, I can't combine them. So this is my final answer. Now we're going to take a look at another one that is a bit more chunkier. Okay, so we're going to try one more example with the complex fractions, and then we're going to do problems from the homework. So stay tuned if you want to see problems done from page 3 of packet 12. I'm going to do 2 problems from that page after this problem. So for this example, I know looking at this here, it's quite a bit. I know, you're probably hating me right now. But it's not that bad if you've been comfortable with adding fractions and also finding common denominators and then dividing fractions. So let me first start us off by just reminding us that we want to always try to simplify the top and the bottom separately. So let's get used to knowing how to separate what is the numerator and what is the denominator. So I'm going to first write my middle fraction line, which is this guy right here, okay? I'm just going to transfer that over. Now I'm going to just focus in on that numerator, okay? This is the numerator. Actually, let me stay consistent. I think I was doing pink. So I'm going to make this the numerator. And I'll come back to do the denominator later, but I'm just going to focus in on the numerator right now. So when I look at the numerator, it says that I need to add this fraction with this fraction. Well, to do that, they need common denominators, and it doesn't look like there is common denominators, right? This factor is different from this quadratic. So I need to make sure that they're the same first. Well, how can I do that? Well, like I said, this one's quadratic. So maybe before we try to find a common denominator, let's figure out the factors for this quadratic equation. Because like anytime you have a quadratic expression, you want to try to factor that first. especially if the denominators are not the same. So I'm going to go ahead and factor the top and bottom. I mean, just the bottom here. So if I were to factor the x minus 2, I need two numbers that multiply to give me negative 4. Well, how about negative 2 and positive 2? Notice that when I multiply negative 2 with 2, I get negative 4, but when I add negative 2 with positive 2, they cancel. And so that means that middle term is not there, and it isn't here. So this works out, and then I have the 3x minus 2 here and the 4x up here. So all I've done is just copy and paste the other things onto where they were before. But I just factored this bottom here. Okay, like I said, I'm going to ignore this guy. I'm going to come back and write him in later. But for now, I am just going to focus in on this numerator here. So I just draw another fraction line, and I'm going to place the top part here now. So to add these two, I need a common denominator. So if you remember from the last journal, we were adding fractions. And to do that, we need a common denominator. So we declare one. In this case, I can take this here, x minus 2, and put that in my denominator. So x minus 2. And then there is an x minus 2 here, but I already have one in my denominator, so I don't have to write another one. But there's also an x plus 2, so I don't have that in my denominator, so I'm going to write that down. Okay, so if this is my common denominator, I have to look back at my fraction that I'm adding and see if it has that fraction. So notice this one has an x minus 2, but it doesn't have an x plus 2 in the bottom. So that means I have to multiply this 3 by x plus 2. So you always multiply the top by whatever the bottom is missing from the common denominator. Now, for this one here, notice that the common denominators is the same. The denominators are the same as the common one. So in this case, you don't have to multiply anything to this 4x. You can keep it the way it is. So I'm going to go ahead and distribute the 3 into the parentheses. So that gives me 3x plus 2. There's a positive sign here. So I'm going to bring that down and then bring down the 4x. So this is plus 4x. Now, when I look back at this, I'm not quite done yet because I can bring maybe the 3x and the 4x together so I can simplify the numerator just a little bit more. So I'm going to draw another line to help show this. So I have x minus 2, x plus 2 in the denominator, and then 3 plus 4x gives me 7x plus 2. So this is my numerator finally done because I can't simplify any further. I can't bring the 7x with this 2. They're not like terms. And you want to keep the factors the way they are. You don't multiply that out. You don't need to. All right, now let's focus in on the denominator here. So this denominator is subtracting, and they don't have common denominators. So I'm going to eventually need to get common denominators. But first things first, I noticed that this here is also a quadratic, and it actually is the same quadratic as before. So I need to go ahead and factor that first. So I have 2 over x plus 2 minus 3x, and if I factor the bottom, I have x minus 2 plus 2, just like before. Now when I'm looking at these two, they're definitely different, so I need a common denominator to subtract them. I'm going to draw my fraction here. My common denominator, let's see, if I grab this x plus 2 and bring it down, it's going to be x plus 2. Then on this side here, I have an x minus 2. I don't have that, so I'm going to bring that down. But this x plus 2, I don't need to bring it down because I already have it. So just x plus 2 and x minus 2. And then for the top here, this is missing the denominator x minus 2 in the top. So I'm going to need to multiply the 2 by x minus 2. But this 3x has everything included in the bottom, just like the denominator here, the common denominator. So you don't need to multiply anything to this 3x. So if I go ahead and distribute this 2 and 2x, let's write it right here. So that would be 2x minus 4 minus 3x. And so when I'm taking this fraction, like I said, I'm only focusing on the green fraction here. I'm going to write it here. So this fraction is, if I combine the top, 2x minus 3x gives me negative x minus 4 over x plus 2, x minus 2. Okay, so when I look at this here, I've simplified the top and I've simplified the bottom. So what I'm going to do next is just divide the fraction. So let me make some room here. Oops. Let's move this to the side. Okay, so this needs to be. I wonder if there's a way I can grab this guy. Cut this piece. There we go. Maybe do that. And then I guess maybe erase this part. Yeah, that works. Okay, so from here, let's try to divide. Sorry about that technical difficulty. So if I'm dividing, I'm taking that top fraction here, the pink one, and I'm going to hold it still. So 7x plus 2 over x minus 2 over x plus 2. And then if I divide, I have to switch the second fraction, so the green one. So if I flip it, I have x plus 2, x minus 2 in the top. And the bottom, I have negative x minus 4. And so I'm multiplying when I'm dividing. So in this case, it looks like the factors cancel out, right? So x plus 2 cancel out with x plus 2, x minus 2 cancel out with x minus 2. And so that leaves me with what in the denominator? So if you look here, oops, sorry, that's a highlighter. All I'm left with is 7x plus 2 over negative x minus 4. And so that is my answer. Okay, so I know that one was a bit lengthy, but like I said, keep the general idea the same. You want to simplify the top and the bottom separately before you try to divide at the very end. Okay, so we're going to do 2 problems next from the packet. All right, so here is problem 3 on page 3. So this one's another complex fraction. But like I said, you want to try to solve the top separately from the bottom here. So if we want to simplify the top here, let me highlight that as pink. Well, if I'm adding these two, I need a common denominator. So I need to start out by finding out like the factors of my denominator. This is x minus 3, so that's a factor, but x squared minus 9, I need to find the factors of that because it's a quadratic. So I'm going to go ahead and do that first. So like I said, the first fraction I don't do much with. This one here, I have a 3x over x minus 9, so 3x on top. If I factor the bottom, if I put x's down, to make a negative 9, I would need negative 3 and positive 3. Because negative 3 times negative 3 gives me negative 9. Negative 3 plus positive 3 gives, well, cancel. And so that's why I don't have the middle term here. There's only 2 terms. Okay, now we're going to try to see if we can add them. But in order to do that, we're going to actually have to declare a common denominator. So I'm going to do that here. So like I said, I'm just focusing in on that numerator, the pink. So for my common denominator, let's choose the factors from each denominator here. So there's x minus 3. Well, there's already another x minus 3, and then I have an x plus 3. So I have x minus 3 and x plus 3. And now I have to see if the fraction was missing anything from the common denominator. notice that this denominator doesn't have an x plus 3. So I need to multiply the top by x plus 3. I'll distribute that in. So I have 2x plus 6 plus, this plus sign here, 3x. Okay. And when I look at it again, I'm still not done. I can combine the 2x with the 3x. So I'm going to go ahead and do that in the next line. So if I combine 2x with 3x, I get 5x plus 6 over x minus 3, x plus 3. Okay. So from here, I can't really simplify any further with the top here. And the bottom, I want to leave it as factors. So I'm finally done with the numerator. I'm going to move on to the denominator here that I'm going to do in green. And so for this one here, it's kind of the same first steps. I need to subtract this fraction from this fraction, but they don't have the same denominator. So first off, I'm going to find the factors of the denominators first. Like this here's a quadratic, so I'm going to need a factor. So I have 3 over x plus 3 minus 4x over x minus 3 plus 3. Kind of this, basically the same factors as before. All right, so from here, if I want to subtract these two, I need a common denominator. My big denominator here. So if I grab the factors, I have x plus 3, bring it down, and then I have x minus 3, bring it down, and then another x plus 3, so I'll bring that down. So I have x plus 3 and x plus, minus 3. Okay, so from here, I have this fraction here, and when I compare this denominator with this denominator here, I have the x plus 3, but I don't have the x minus 3. So I'm going to multiply the top by x minus 3. And so if I distribute this 3 into each term, I have 3x minus 9 minus 4x. And so if I were to just simplify the top here, maybe, I would keep the factors, but maybe bring the 3x and the negative 4x together. Okay, so looking at this, I've simplified the top and the bottom, so now I get to divide the two fractions. So when I'm dividing here, see if I can pinch this. Okay, guess not. Okay, so when I'm dividing, I have 5x plus 6 over x minus 3. Oh, sorry, I'm getting ahead of myself. I should do this in corresponding colors. So this I can write as 5x plus 6 over x minus 3 over x plus 3. And then I want to multiply this with the x plus 3 and the x minus 3, which is 5x plus 6. So when I'm looking at this here, I can see that the factors wipe out. Oh, my bad. I think I messed up here. This should have been negative x minus 9. And so when I look at this here, if I multiply straight across, right, this here is just a negative negative x minus 9. And so when I look at this here, I just have 5x plus 6 over negative x minus 9. Whew. And that is my final answer. I know that took quite a bit of work, but like I said, the principles same apply. You need to separate the numerator from the denominator. Okay, so what we have here is number 4, and if you look at this problem in the packet, I've highlighted the top because, you know, we're going to simplify the top and bottom separately. So here we go for simplifying the top. So for the top piece here, let me just rewrite that middle fraction line. So for the top, I have two fractions subtracting each other, so I need a common denominator, and they don't have it right now. So I can declare that common denominator to be x plus 1 and x minus 1. And so when I look at this fraction here, this denominator is missing x minus 1, so I need to multiply the top by x minus 1. Whereas this side here is missing x plus 1, so I can multiply this too by x x plus 1. So when I do this, let's see what I have for the top. So when I distribute this 1 into here, I have 1 times x minus 1, so that's going to be 1x minus 1. And then this here, I'm distributing this negative sign along with this 2, so that's really going to be negative 2 that I'm distributing. So if I distribute that negative 2 into here, that's going to be negative 2x minus 2. Okay, so in the top here, I'm going to just try to simplify this numerator here. So if I simplify this, I can combine the x's with the x's and the numbers with the numbers. And so that gives me negative x minus 3, right? Because the x with negative 2x gives me a negative x. Negative 2 minus 2 gives me negative 3. And then the bottom is just x plus 1, x minus 1. All right. Okay, top and bottom are simplified. Now I'm going to try the denominator here. So here I go. If I am adding these two, I still need a common denominator. So that's what I'm going to do here. So if I want a common denominator with these two, let's pick out the denominator that's already in the denominator. So it looks like it's x minus 1 and x plus 2 as my common denominator. So same as before. And then for the top here, I need to multiply what's missing in the denominator. So I'm missing x plus 1 in the denominator comparing to my common denominator. So I'm going to multiply this guy by x plus 1, whereas this one's missing x minus 1 in the denominator. All right, so when I multiply by distributing, I get 2x times 2, 2x plus 2, plus 1 times x and 1 times negative 1. So that's going to be plus 1x minus 1. And now I'm going to combine like terms. So I notice that the 2x can be combined with the x and the 2 can be combined with the negative 1. So that's going to give me 3x plus 1. And then it looks like my denominator is those factors. All right, so I've simplified the top. And I've simplified the bottom. So now I get to divide the top and bottom. So I have, let's write the top one here, negative x minus 3 over x plus 1 over x minus 1. So remember, I'm taking this fraction, keeping it still, and I'm going to flip the second one. So if I flip this one here, that's going to be the factors in the top, or in the numerator, over, for 3x plus 1, and then I multiply straight across. When I do this, I notice that the factors diagonal from each other cancel because they're identical. So I can cancel out the x plus 1s because they have one each on the diagonal, so they can cancel, and x minus 1 can cancel. They're diagonal from each other, and so if I multiply straight across, that's going to give me negative x minus 3 over 3x plus 1. And so it looks like this is my answer here. So I'm going to box that in. And that's it, guys. I hope that helps a little bit with the homework and understanding these problems. They are a bit lengthy, but they're not too bad. They're using a lot of skills that we've learned in the previous lessons. So if you haven't watched the previous videos, make sure you do.